Okay, so now that we've talked about simplifying square roots, let's talk about square roots with variables. So this means that we're going to be dealing with letters and numbers now. So we have to still take into account the rules that we just talked about for numbers. But let's talk about the rules when we have variables. So if you're given the square root of a to the m, if m is a multiple of 2, then we can use the rule the square root of a to the m is equal to a to the m divided by 2. So say it was like the square root of x to the fourth. 4 is divided by 2. This answer would be x squared. But what if it's not divisible by 2? So if m is not a multiple of 2, then we're going to break it apart. So we're just going to make one power that is divisible by 2 and then 1 on its own. So this would be like the square root of x to the fifth. We want to break this apart to be x to the fourth. So that's what that m minus 1 means. Just go down one power, and then we're going to multiply this times x, because we know from exponent rules that 4 plus 1 is 5. And so this is the same thing. We just broke it down. And so this would be x squared times the square root of x. All right, let's do some more examples of this. So really all we're trying to do is make sure that our variable can be divided by 2. And if it's not, we're going to break it apart and just take 1 away. All right, so let's look at the square root of x squared. This can be divided by 2. So this is really just x to the 2 over 2, which is 1. So this is just x. Then we have 9k to the 10th power. So we're going to break this up. We're going to do our numbers. We know 9 is a perfect square. And then 10 can be divided by 2. So this is really k to the 10th. So the square root of 9 is 3. And this is really k to the 10 divided by 2, which is k to the 5th. You don't have to write that step unless it just makes sense for you. All right, so let's look at the next one. So again, we're going to break this up. We have our numbers. So we have the square root of 25, which is a perfect square, so we don't have to simplify that. And then we have 6 can be divided by 2, so we're going to have the square root of x to the 6th. And then 13. 13 cannot be divided by 2, so we're going to drop down one power, so y to the 12th, which can be divided by 2, times y. And now let's simplify. The square root of 25 is 5. X to the 6th, the square root of x to the 6th, we divide 6 by 2, we get x cubed. Y to the 12th, we divide 12 by 2, we get y to the 6th. And then we have our leftovers. So our answer is 5x cubed, y to the 6th, square root of y. On the next example, we're going to break this down. So we have negative 2 on the outside, which is going to get multiplied to anything that we take the square root of. We're looking for factors of 180, so we have the square root of 36 times the square root of 5. U squared can be divided by 2, so we'll put that there. And then we have the square root of v. All right, now let's go ahead and take all of our square roots. So we have negative 2, the square root of 36 is 6, the square root of u squared is u, and then we have our leftovers. So we did the square root of 36, we did the square root of u squared, and so we have 5 and v. Now we want to simplify, so let's multiply negative 2 times 6, which gives us negative 12 u, and the square root of 5v. And there's our answer. All right, so what about cube roots? Well, we said that with square roots that the variable had to be divisible by 2. And so for cube roots, m must be a multiple of 3. And we use the rule a to the m divided by 3. If it's not a multiple of 3, break it apart so that it is. And then remember, we always can have those leftovers. All right, so let's look at our examples. We have the cube root of x cubed. So again, remember we know 3 is a multiple of 3, so it's 3 over 3. And that just is equal to x. On our next example, we have the cube root of 64 m to the 9th. 64 is a perfect cubed. So we have the cube root of 64 times the cube root, and 9 is divisible by 3. So remember, that's just m to the 9 divided by 3. So our answer here, the cube root of 64 is 4, and this will be m cubed, because 9 divided by 3 is 3. We look at our next example. We have 2 on the outside of this cube root. So remember, everything that we do is going to get multiplied to 2. Then we have a negative. So remember that our perfect cube root will have a negative on it. So we have factors of negative 250 would be negative 125 and 2. So we have the cube root of negative 125 times the cube root of 2. And then a cubed, 3 is divisible by 3. So we have a cubed. And b, we're just going to change this to be b cubed times b. So we have the cube root of b cubed times the cube root of b. All right, let's go ahead and take the cube roots of anything that is a perfect cube. So we have 2 times the cube root of negative 125 is negative 5. And then the cube root of a cubed is a. And the cube root of b cubed is b. And then we're going to put anything left over in a cube root. So we have 2 and b. And then we're going to simplify. We're going to multiply this 2 times negative 5, gives us negative 10, a, b, and then the cube root of 2b. All right, let's look at our last one. First, we're going to simplify 192. That is the cube root of 64 times the cube root of 3. And then 8 is not divisible by 3. So we're going to break it apart so we have something that is. So we can't add, but we can take away. So we have r to the 6, because 6 can be divided by 3. And that means that we're left with 2 r's. And then we can't do anything with s. We can't add in an s, so we just leave s squared. It's going to be part of our leftovers. And then 18 can be divided by 3, so we have the cube root of t to the 18th. All right, let's go ahead and take all the roots that we can take. So we have the cube root of 64, which is 4. We can take the cube root of r to the 6, so that would give us r squared, because 6 divided by 3. And we can take t to the 18th. 18 divided by 3 is 6, so t to the 6th power. And then we're going to create a cube root here and put all of our leftovers. So we have 3, we have r squared, and we have s squared. And so our answer is 4r squared t to the 6th cube root of 3r squared s squared.